The JetBrains Kotlin ecosystem consists of a lot of different tools and frameworks that let you build really cool things with Kotlin. Today, we want to explore another one of these tools, specifically the Exposed Database Library, which recently shipped its 1.0 release. This is Talking Kotlin. I'm your host, Márton Brown, and as always, I'm joined by my lovely co-host, Sebastian Eigner.
Hello, hello.
And today we're sitting down with Chantal from the Exposed team to talk about where the library comes from, what you can use it for, what's new with the 1.0 release, and what else they have coming up in the future. Hello, Chantal. Welcome to the show.
Hello to you both. Thank you for having me, and a very good morning from here in the eastern coast of Canada. How are you both?
Very good. I mean, it's time zones are always a fun bit about this. Here, the sun is just about to set, so I'm still catching a couple of the final sun rays here. I'm guessing, Márton, you don't have something else to report from your time zone, huh?
I have a shockingly similar time zone to yours, but I have a bedtime much later, apparently, so...
Hey, that already works.
Yeah. So let's start with the high-level question. What is Exposed and where does it come from?
So, Exposed, at its most simplest form, at its core, is a Kotlin SQL library. So it provides a type-safe DSL that allows you to build queries with the extra safety nets provided by a Kotlin DSL. So type safety, null safety, compile time checks, and in a way that feels and reads closely to plain SQL. But for people coming from a more ORM approach, Expose also offers an alternative option. It offers a lightweight data access object framework using entities. And regardless of whether you choose to use the DSL or the DAO approach, one of the goals of Exposed is to offer simplicity over your database access interactions, hand in hand with flexibility. So, regardless of whether you use DSL or DAO, it offers automatic transaction management, connection handling, and releasing of resources. And if you choose to actually have more fine-grained control over those instances, you can also access all the underlying mechanisms of Exposed. A lot of other things that Exposed offers are database agnostic approaches. So you can choose to use one or more of the supported databases with little to no actual vendor specific code. It also offers ease of integration. You could choose to use Exposed with a JVM JDBC standalone app. If you want to use it with Ktor, great. If you choose to use maybe Spring Boot, same thing. And Expose provides all of this while embracing and leveraging Kotlin features that don't force you to compromise and allow you to continue to write in concise and expressive Kotlin code.
This sounds really excellent. And it also sounds like Exposed can do quite a lot of things. So maybe the first question that one might ask in this scenario is that there's obviously other libraries that allow me to access my databases in some ways or another. You mentioned that Exposed has a DSL, but you also mentioned the term ORM. Uh, Probably we're also going to be talking about DAOs. Do you want to give us like a little bit of an overview of how the approach from Exposed is kind of perhaps unique or differentiated from some of the other libraries or approaches that are out there?
Sure. So, like I said, there's two approaches, so you have at the core the DSL API. And if you're coming from a background where maybe you're more familiar with SQL or you've embraced SQL, it offers the same possibility to use your SQL strings or convert them to a Kotlin DSL, but you still gain the benefits that maybe other libraries may not have of the extra safety nets that Kotlin provides. If you are coming from an ORM background, you know, The DAO is a abstraction level up on exposed. So even though we offer a data access object approach using entities, at the core, the abstraction is still the main table object. That's a single source of truth. So there's more control, there's more visibility over the underlying SQL, even if you're using the DAO approach. It still offers very common ORM functionalities. For example, the entity change states are automatically tracked. So if you have things, for example, like repeated updates, when the transaction closes, you're still just getting the single most accurate SQL statement being generated when transaction closes. It still has a first level transaction scope cache that minimizes unnecessary reloading or refetching of the entity instance during a transaction. And it offers, like many ORMs, a much easier overall relationship management if your entity has foreign keys in other tables. But what the core goal of Exposed is to be much more lightweight and much more transparent and offer the flexibility of choice. And I think that's one of the better features of Exposed, that it gives you control to use as much or as little of each approach to solve whatever the problem is that you need to solve. It's very unopinionated about its approach. So at the highest level, if you want to choose to use the ORM, to use the DAO, to have as much separation from your database layer, you can. And then as maybe your app evolves and you need to be integrating more complex queries, you can go down a level and you can introduce the DSL syntax, because that gives you more fine-grained control over how you're building queries. The DSL is very what you see is what you get, but using Kotlin without actually having to rely on strings. So, if your table changes, your table migrates, it evolves, it's reflected and warned in your Kotlin code. And then you can even go down a level. You can say, I'm migrating from an existing project, for example, and I have all these SQL strings that I want to port over to my new project. Expose doesn't stop you from still relying entirely on these SQL strings. If maybe you want to start your project with that and then eventually pick up the Kotlin DSL, there is API available that allows you to put in your SQL string. You can even use placeholders and set arguments, and it will send the SQL string to the database, get any results back if there's any, all while still abstracting away things like the transaction management, connection handling, so you don't have to deal with that. And then at the absolute lowest level, which is nice because, like I said, nothing in Exposed is hidden. At the lowest level, you could very well choose to access the connection retrieved from the driver or the connection pool if that's what you're using. And you could use JDBC as lowest level. You can create statements, prepare them, set the fields or set the arguments, add it to a batch, and send it to the database. And I think that breadth, having a tool that assumes you, the user, know best and lets you use it however you want, I think that distinguishes Exposed quite a bit from other ORMs.
So we kind of have like an iceberg going on here, where we're at the very bottom layer. We can really just we can pull out the actual connection. We can do whatever we want with that, whatever JDBC as like the standardized database connector API allows us to do. So on top of that, there's like you said the most basic layer is working with SQL strings. And having your queries that you've pre-written or that you may have already written at another point, and just running these effectively through the exposed machinery, which means, am I getting extra type safety in that scenario already somewhere?
So if you were, for example, just taking straight SQL strings, plugging them in, then it would be straight SQL strings. That would be at your discretion and at your what's the word? Yes, you
I
would
guess the
need to handle that
responsibility is
at your
okay.
responsibility. Yes, but as part of the API, you could technically the strings that you could be inputting could have placeholders. They could have prepared parameters to prevent SQL injection, things like that, for example. And then there's a extra layer of API that when you use those type of SQL strings, the arguments that you're setting are type checked because you have to provide a type. But for example, if your table changed and you dropped a column or added a column and it was no longer there, that would not be reflected in the string. You would need to rely on the DSL for that.
I mean, yes, that makes perfect sense. So this is then where the DSL comes in, where effectively we have a re-implementation or a Kotlin native way to specify the typical things that you would otherwise express in SQL. So rather than typing everything into a big string and then relying on like an interpreter to interpret that, you would effectively write, I guess, Kotlin function calls that maybe take other lambdas, and thanks to our wonderful trailing lambda syntax, that means you can build really nicely like nested structures and so on. You can still write selects, you can still write joins, but because Kotlin DSLs are a first-class feature in Kotlin as the language, and they also integrate properly with generics, I'm guessing this is exactly the point where we start to see a lot more type safety being introduced to our database code, right?
Yep. Yeah, it's more type safety, more null safety. So if you have columns that are nullable, we'll make sure that they're either the value that you're putting in is valid or not. And in addition to and sort of on a same stream of type safety, one thing that's really great, given that it's a Kotlin DSL, is the verbosity or lack of. We try and align the Kotlin DSL with SQL. So, you have the table as a main object, which is maybe the one core difference. So you don't say select, you say main table, that's what it's from. And then you start selecting where, order by, and you can stay with that, or you can separate each chunk. You could have predefined conditions, for example. So you could know that in your database, you are very frequently checking for a condition where status is active. And you can store that. You can make your own extension function on a query, store that inside the Kotlin property. And then so you can start writing, you can make your own DSL. You can start saying, users, and then literally say where status is active. So you can make it as readable as you want to. And I've always thought that was quite nice, especially depending on who you're sharing this DSL with.
Yeah, I mean, this is kind of like it's a really incredible feature that we also see in some of the other like DSL heavier libraries, like Kotlin X HTML, I think is the other classic one that often gets thrown out there. At first people go like, well, why would I want to write HTML, but it's kind of like represented as Kotlin functions? But then you also realize that, oh, well, now you could just have a for loop in there, and it's just going to create a little bit more HTML for you. Or, oh, I can just rip out this part of my HTML declaration and have it live in a different function, or I can parameterize it and then have that essentially be like injected back. And I guess it's no different here with exposed. You can break up complex queries into regular Kotlin functions. You can reuse them. You can like parameterize them, which is all like extremely powerful. And then this isn't even where exposed stops. This is like the layer where we got with the DSL, but then we also got the like ORM. So it's object relational mapping, right?
That's correct. Yes.
And that is also then what gives me my DAOs, my data access objects.
Yes, and it gives it's much less verbose. It is sitting on top of the core DSL, so we are using it under the hood. But when you're actually interacting, you're interacting with these Kotlin objects, these instances. So the entity classes, they come with a much simplified CRUD operations. So, instead of inserting or selecting all, you're just using classical kind of object-oriented methods like find by ID, all, So one could argue that choosing to use DAO, for example, would potentially result in like an easier startup for your app, more rapid productivity right off the bat, because it comes out of the box with all these simplified operations. But you can mix and match, and that's a great thing. You have this ORM, but if you wanted, for example, a slightly more complex query, you can still rely on these methods. You don't have to wrap a DSL method into a new ORM method. There are existing ORM APIs like find, where then you can basically create your own kind of DSL clause that maybe is a little bit more complex. So there's a really nice flexibility of choice offered by Exposed.
I think you got to explain that last part to me a little bit more, because you said you can customize it as part of the DAO approach.
Yes, because so what we do is when you think about our query builder system, we have queries, and so we instantiate a query off of some sort of object that offers a set of columns, and usually the very traditional object is the table. And so you instantiate a query instance by usually selecting something, either all columns or a subset of columns from the table. But then after that, you have all the options with SQL. And the really big one is the where clause, right? But then we break it down even further. So every condition, every function, every operator you can think of that is valid SQL syntax and is mapped to an exposed class, it's not locked into the context of the query. So that's why I said you could, for example, create your own repeated use conditional that you store separately, and you store it as like an extension function on a query. So for DSL, you can take these SQL functions. I call them SQL functions, but they're obviously exposed Kotlin functions that map to. And so you can take them, create your own little conditionals, like, this column is null, the value is null or is not null. And then it basically store it as a named conditional clause. And then you can pass it as an argument into the Lambda block of some of the DAO methods, like the find method. And basically you're just inserting a property, but what you're doing is telling the DAO that when you're crafting this underlying select all statement, that you're adding this conditional to the where clause. So you can mix and match in that way.
Wow.
And then all of this eventually gets translated into SQL queries.
SQL.
And
yes,
it all runs in the database.
Yep. And one of the core goals of Expose is transparency. So obviously, with a DAO approach, we are trying to abstract further away from the database. You can still have access to all the actual strings that would be sent to the database without actually sending them. It's much more easy to attain them from the DSL, but it's still available from the DAO. So, you can always write out all your queries in Kotlin, store them in properties, and then you could check them by either preparing the SQL, printing off the strings just to compare. In the past, pre-V1, you could only do this with queries. So you could only do this with select statements. With V1, it's now possible to do that with any statement that Expose allows you to create. So whether it's an insert, an update, or a delete, you can actually build the statement to pre-check that what is going to be sent to the database is what you want. Whereas before, it was a little harder. It was not impossible, but it was harder to do that because Expose wanted to automatically send those those insert, update, delete statements to the database.
So let me ask about some of the like syntax basics here to orient ourselves, because we've looked at all of these different levels of abstractions that you can work with, where you can use the DSL with your tables, or you can also have entities on top of it with the DAO approach. So let's take a look at what each of these bits would look like in code. So for example, when we say we're working with a table in exposed, what does that mean in Kotlin syntax?
So at the core level, you have the table. And so if you have a database table, it has rows, it has columns. In exposed, the traditional approach is to create an object from the table class. So you're creating an object that's a table. You can have the basis level of a table. We also offer some simpler subclasses that already come, for example, with a primary key, or that come with an identifier column, just to make things a little bit easier. But the base table, you create an object, you extend the table class, you provide the table name, and then within that table object, you are basically creating properties on that object, and they are created and stored in properties by calling registration methods. So if you want to have an integer column, you're calling the integer method, you're naming it, and you can do this for as many or as few columns as you need. And then on each column, that's once again stored in a property, there are multiple column scoped chaining methods. So you can alter the final identifier for that column. So you have an integer column, you want to make it nullable, you chain a nullable method. You want to make it a unique index, you chain that method. You want to add a comment, you chain that method. And then there are also table scoped methods, so creating primary keys, creating foreign key constraints, creating indexes. These are all things that you do within your table object. And that, at least with the DSL, is a single source of truth. That table object maps to your database table, and from there, the DSL is built on that table object.
So I'm describing the structures that exist or that I want to create in my database with this object. I have the structure of every table, like or every column in a property with these little like mini builders that describe the properties. And then, because this is an object, I can just grab the object reference itself, and that's where I start from to actually work with like operations, right?
Exactly. So all your inserts, your updates, your deletes, every statement that we support has an extension function on the table class. So you can take your object reference and you can just start from there.
And when I run one of these with the DSL approach, what do I get as a return value, right? Like when I queried a bunch of users, what do I get back from one of these queries?
So if you're doing a query that is expected to return results, Expose has an API called a result row. And so if your query is expected to return results, usually in a standard, like at the lowest level of JDBC, that would be a result set. It would just be another temporary table that has the columns, the fields, and the result values. And Expose maps that to something we call a result row, which is very similar in its structure. But what it allows is that once you have that result row, you can then, for example, map it. You can extract each field based on the table column. So if you have a result row, you just need to use a get operator with the table column, and it will return the result of the value that you would have expected from the query.
And that's still type safe because I'm somehow grabbing the column itself, like I'm grabbing a property, so it's like a property reference.
So Expose will handle the conversion. So part of the reason that we map to a result row is that we are handling how to convert that value back into a format that you want. So for example, if you have maybe a slightly more complex column, like a JSON column, that uses like a case serializer, for example, part of the logic when you're registering that column is that you're telling Exposed, I have this column, I'm going to be giving you this data class that uses this case serializer, and you're going to be using that to send a JSON string to the database. And then when you select, that database is going to send back a JSON string, and you're going to deserialize it back into this data class object. So you're telling Expose how to handle that value to the database and the value from the database. And then when you perform a query and we are Expose under the hood does the result row mapping, it means that all you have to do is attempt to get that table column, that JSON column, and we will parse the result back so that you get your data class instance that was stored as a JSON string.
Mm-hmm. So I guess this allows me to do just arbitrary conversions both ways into the basic data types. So like typically like a JSON into string and things like that.
Oh, well, I was just going to extend on that. So you're allowed to do conversions between types, but once again, because the message we're trying to send about Expose is that you can have control at whatever level you want. So you can rely on our types, you can rely on our mapping for our conversions, but then we have different API, for example, that allows you to say, no, I want you to use an integer column, but I'm going to append or chain this transformation method onto these columns to tell Exposed every time I'm going to give you an enum instance, for example, like a Kotlin enum, and then you basically, it's almost like programming a serializer. You're telling Expose, this is the transformation from and to. So we're going to give you an enum. You're going to transform it this way, store it in that integer column, and then when you get it back, this is the transformation that you do. So we offer different levels of data types, to get exactly what it is that you need.
I think I don't know if it's an example because you might have an abstraction on top of this, but I am reminded that despite being extremely popular and having a reputation for being extremely resilient, everyone's favorite database, SQLite, is playing surprisingly loose with its type system at times. For example, I know that they don't have a Boolean type in the database, and they're instead just doing integers like 1 and 0. I don't know if you have something that just already abstracts this away, but it just came to mind for me as like, well, if I wanted a Boolean column, then I could probably just write my mapping function to write out a 1 and read back a 1 and turn that into a Kotlin true.
Absolutely. Like there is API that if you wanted to have a Boolean column, but your Booleans were A and B letter character, you could chain a transformation to it so that you would just tell Expose, this is what you do. Just do it. Trust me, it will work. Just do it. So it's at your prerogative to do that. SQLite definitely they have an interesting type system that has led to a few edge cases and a few bugs. But usually the type mapping that we do when we register columns, we try to take into account the SQLite type system. And that's another nice thing about Expose on that level. Let's say, for example, you have a database and you know that we map integer to an INT, the SQL INT syntax when it's creating a table. If you don't like that, let's say you're using Postgres, Postgres has like INT4, INT6, INT8, depending on how many, if you wanted, you could override the dialect defaults and you could say, oh, no, I actually want this type to map to this. So I'm going to change the SQL type. So we also offer that.
I guess this is a good time to ask, what are all the different database types that Expose supports? Could we use it with SQLite, Postgres?
Yes. So we support some of the major ones. So we support H2, Oracle, SQL Server, MySQL, MariaDB, SQLite, and of course Postgres. So yes, we do support the big ones. And if your next question is going to be, are you going to support any more? The answer is probably more, when and which ones. It's certainly something that we've been asked before, and we're kind of keeping our ears open about, going through user feedback about which would be the most impactful additions in the future. So it's definitely something that we're taking into consideration. But so far, just those 7.
Well, quite frankly, my next question was one that is of much higher impact, which is it SQL or is it SQL?
I personally say SQL, and I don't know who I'm going to offend or who I'm going to make unhappy about that. I have always said SQL. I really hope I have not been wrong this entire time.
I don't think there is a correct answer. I tend to just switch between the two to annoy as many people as possible. And quite frankly, before, like with the SQL pronunciation, I think for SQLite that works perfectly, but I have absolutely no idea how I would pronounce Postgres, because PostgreSQL sounds odd.
Yeah.
How
Yeah,
about SQLite?
I say SQLite personally, and I think people say PostgreSQL, but I just play it safe and I say Postgres. I don't. But then, do you say MySQL or MySQL?
Again, I intentionally switch between the two. You gotta keep people guessing. Yeah, you gotta keep people guessing.
I've just realized that we've had the huge and very high effort missed opportunity here to just record the episode twice. Where in one version we say SQL the entire time, and the other everything is SQL.
Of course.
Maybe we can just substitute it in post.
in post what?
Post production?
That Postgres. Anyway. Okay, back to something maybe slightly more related to what we were actually talking about. We've been talking a lot about types and type mapping and conversion and so on. And now my actual question, not having seen any of the implementation details of Exposed, is this all just the Kotlin type system plus DSLs at work? Is there code generation going on? Is there reflection in there? Is there like a compiler plugin magic happening? What's the story here?
So it's a lot of properties. It's a lot of classes. It's reflection currently is really only utilized by one type, by the enum type. We offer 3 different flavors if you want to be handling Kotlin enums. We offer by ordinal, by name, and then a custom one that's more synced with the database level enum, and that relies on reflection. Other than that, reflection is really only primarily in the DAO layers. We do use reflection quite a bit there. But yeah, it is all just Kotlin DSL. Code generation is something that I can definitely go into. It is currently not a part of Expose, but there are feelers in that area if that's something that you wanted me to touch on now.
I
or
mean, yeah,
later.
I'm happy to dive in now. No time like the present, because that's very curious. Because I'm guessing that means that there's some potential upside to doing that over the current approach.
Well, yeah, the huge pain point, I suppose, that we would want to be addressing by introducing either code generation or some sort of like compiler plugin, for example, would be boilerplate code. And also just addressing how somebody picks up Expose, because let's say, for example, that you're choosing to try Expose, but you already have an existing product, an existing project, you already have an existing database. If you choose that route, you have to create a table object to start from there. And then if you want to go into DAO, you now need to create an entity class. So that entity will map to each row in the table, and all of the entity's fields will delegate to columns in the table. And then on top of that, more than likely, there's a very common pattern where, you have your database, and then you have models that use data classes to map to the tables. And usually that results in a pattern where our users create a lot of conversion extension functions. So when they're, for example, using the DSL or the DAO to select or fetch data, you have to create all these conversion functions from the result row or from the query iterator to your data class instance. And so you're ending up with a lot of boilerplate code that we are very aware, can potentially be time consuming and maybe not as fun to always have to write, especially when you have tables that can have, a bajillion columns. So we're looking at multiple different levels where we can address this boilerplate. So for example, there is currently an IntelliJ IDEA plugin that's available. It is still very fresh. But one of the features that it provides is that if you have an existing database, you can auto-generate the exposed table object and all the entity classes with just a couple button clicks. And I think that once it's polished, it's going to be very, very cool to use, and it's going to save a lot of time. We're also experimenting with other options entirely. We're looking into whether there's other solutions to avoid entirely having to have all that boilerplate. Whether we need to maybe rethink the design of our DAO and how those entity classes are actually interacting with the Kotlin, with the DSL layer. We're also looking at some plugins related to how data classes have a relationship with expose. So all those conversion functions can become time consuming that I mentioned, from going from result row to data class. And we're looking into some plugins that would allow you to take your existing data class and automatically generate those conversion functions for you, as well as like other data class potentially valuable extension functions like CRUD extension functions. So you'd be able to say something like data class, your data, like user data dot insert. So you would be able to create an extension function on your data class that would map automatically to Kotlin to expose DSL. So we're looking at plugins like that as well.
Interesting. I'm a huge fan of the whole story of I think some communities call them generators, like the
Yes.
idea of having like a data source or some sort of model or schema, and then just being able to pull this into your own code. I think in the iOS and Objective-C world, if I'm not mistaken, the core data abstraction layer that they have for database management does something quite similar, where you draw up your relationship diagram like in Xcode and so on, and then like somewhere out the other end also falls like an accessor class that you can write queries against this wonderful graph that you've constructed. I find this is maybe a little bit far in the point and click like area, but having like existing schemas and not having to reconstruct them in order to still get the entire benefits out of them is, I think, something super cool. It really sounds like there's a lot of stuff that you folks still have, at least potentially, or that is still in research for exposed.
Oh yeah. If I can maybe take us back a little bit, the goal of 1.0 was to address as many bugs as we could, particularly the long-standing bugs. It was to address as many of the old feature requests as we could, and the primary one was R2DBC. But we always knew that we weren't going to be able to get 100% of everything that Expose has the potential to be into 1.0. It would also, especially as we were progressing to 1.0, we realized how much of a migration it would become. There's an entire migration document that's available on our documentation website, and we acknowledge that it's a lot. It's a big change. There's some big changes in there. And yeah, I think it's exciting that there is still a lot more to come. And I'm pretty sure that even if we get all those plugins up, if we, improve our DAO layer, if we address all these long-standing issues, there's probably going to still be some big ones. And in my mind, that big one is it's kind of most days I think it's kind of like having a neon sign blaring behind me, emitting heat that just says KMP. And like Kotlin multi-platform support is a huge. It's probably the last remaining long-standing feature request that's on our GitHub page, and we're very aware that many people are excited about the possibility of Expose supporting KMP. There's an open ticket for it on UTrack. It addresses all the blockers currently, all the questions that we have that we would need to answer first. For example, platform specific drivers, what's available, what can we use, what will users expect to use? Is there a unified API or specification in the same way that there is with JDBC and R2DBC, or would Expose be expected to provide a built-in integration like with SQLite for Android? So we have all these questions that we need answered. I mentioned briefly reflection is quite prevalent in the DAO module, so more than likely KMP will not be started until DAO is sorted out. So the short answer for KMP support is that we're very aware of it, but it would be another huge endeavor, and our goal right now is to lay the groundwork so that we do it right when we do support it. And so yeah, we can't commit to a definitive timeline for its release just yet, but the neon sign is on and it's blaring and we see it. It's in every room, and not just externally within JetBrains. I've had a few of my colleagues be like, so when's KMP support coming? Like, eventually.
I mean, I can imagine that this is it's very much a non-trivial point, because, like you said, especially when you're adding native to the mix, the question all of a sudden of like the common denominator that you can build upon, like all of a sudden becomes a lot more low level. And then the question really is like, so are we interfacing with the just via a C API, of what should we do there? If Ktor is compiling against Kotlin native, like what should the story be then? Are we doing Postgres drivers on the server side but native? Like there's the problem space seems practically infinite. So I can understand that trying to find the right set of constraints and abilities so that you end up with something that ends up making a chunk of our users more productive. Finding that takes time. I absolutely see that that's not something you can just whip up over a weekend.
Yeah. Yeah. I will say though that I'm very happy, obviously that 1.0 happened, and I know it was a huge change. The refactoring, the redesigning was huge, but it was very necessary, and it was also really good, not just for information gathering for the future, but kind of like laying a stability for the future. There were a lot of redesigns that we made, not just to make R2DBC work, but to better improve the code base for KMP. So there was a lot of I guess to put it plainly, the exposed core module had almost too much going on in there. There were a lot of JDBC and Java specific API elements that were just kind of eventually over time left in. And so we had to extract a lot of that to the actual JDBC module so that we could introduce R2DBC. So the introduction of R2DBC really gave us the opportunity to kind of take a really deep look at the code base and go, how can we truly make the core the most common denominator? What can we take out? What do we leave to make sure that in the future we don't need to worry too much about all these little extra Java things that are hanging around? So it was a good opportunity to really kind of redesign the core architecture of the code base.
I have about 100 questions that I still want to dive into, but maybe one that's quite fundamental, or maybe even generally applicable. You said that for the 1.0 release, the code base was significantly restructured, refactored, redesigned in some ways. The Of course, extraction of JDBC related things into like dedicated modules and so on is one part of that. But I'm very curious how such a redesign is actually approached from an engineering standpoint. Like, because you first, to understand how you might rebuild something that was already built, I guess you need to have a good understanding of how it's used, of where all the sharp edges are, and then somehow formulate a plan to get to a better outcome in the end. And I'm just wondering how this was approached, because again, like exposed, it's not a small library, it's not a particularly like simple like library. It has quite the API surface, and it has users.
Yeah.
So yeah.
Yeah, it was approached with a lot of care, but also a lot of so many proof of concepts. We went through so many iterations because at some point it was kind of like I can spend 40 to 50 hours just trying to think of how I'm going to approach it, and then I'm actually, what? No, I'm just going to do it. So there were some proof of concepts that were sort of just we're just going to start from scratch and rip everything apart and see how it all fits together. But it took a lot of there's a massive mirror board that we created where it was every single class interface that existed in the core API. We added how they were all connected, what they would look like when we separated them into JDBC versus R2DBC. A lot of it was, initially basically defining everything that was from a Java package, finding where they were, what they were used for, what depended on them, because they would all have to be removed and replaced with the R2DBC variant. And then there were a lot of little roadblocks that came up because as you're doing that, you realize, oh, wow, everything needs to suspend now. If we're doing R2DBC, almost everything has to suspend. So, it was also defining the actual responsibility of every single class and interface we have. And the best example I can think of is like the statement class. So the statement class in our core is the most base level class for every kind of SQL statement you can think of. So whether it's insert, update, delete, or select, or any kind of custom. So it's obviously customizable by users. Initially, this statement class did three things, which is already too many, but it did three things. It defined how you prepare the arguments that a user will actually input, in their Kotlin DSL code. It defined how you prepare the actual SQL statement that's going to be sent, so the syntax that's used depending on the dialect that they have. And then lastly, it actually defined the logic behind how we execute or send those statements to the database. So it's doing three different things, two of which are done in completely different ways for R2DBC versus JDBC. So we basically gutted the statement class. It still exists in the core, but now all it really truly does is what it should have probably always done, which is define the logic behind preparing the SQL, the syntax for that statement. That's in the core. And we separated the other logic into an executable class. So we have a blocking executable and a suspend executable, whether it's JDBC or R2DBC. So yeah, the approach overall was really kind of like a very intense workshop into how Expose works, logging and reporting everything, how everything connected, and then seeing what would break, and then actually doing it and realizing that 5 more things broke, and then figuring out how to fix that. So it was a process. It was a process, but a very valuable and very necessary process, because my hope is that no matter what we implement in the future, whether it's a DAO redesign or KMP support, we won't have to go through that same sort of upheaval. Is my hope, because of the changes that we've made. Things are much more in their place and the place that they should be, and much more single kind of responsibility, separation of concerns, all that. So hopefully, we avoid that kind of upheaval in the future.
Yeah, that's definitely what I'm hearing, is that besides having a 1.0 for users to comfortably build on and to know that it will evolve from here after all of these changes, that we also have as an outcome a team of people who very, very deeply understand how the library works and the problem space, and who will know how to fit all the remaining puzzle pieces that are there in user and feature requests.
Definitely. And I also think that I'm hopeful that we've made it easier for any future maintainers, if anybody wants to join our team in the future, that, we've made it easier for them to navigate the code base. It's open source as well. So, we've had a lot of people who've contributed in the past and have continued to contribute. And the hope is that it is just a nicer, easier, more maintainable source code now as well for all of them and for us.
Yeah. We also mentioned R2DBC many times here as like a primary driver of change and work. Can we maybe focus in on what that support means and how it works, and what do you get out of it if you're using Exposed?
Sure. So the JDBC is the blocking API driver, and that is the traditional driver that Expose was built on. So it's much more robust, much more mature support. With V1, we introduce the ability to pass R2DBC drivers when you're connecting or you're instantiating an R2DBC database instance, so that you can connect using a non-blocking asynchronous API. We endeavored to apply the same features across both. There's obviously some restrictions, some limitations, some differences based on the underlying R2DBC specification. So depending on databases, for example, SQLite does not support R2DBC, so we don't support it. There are certain data types, depending on the database, that don't yet have R2DBC support on the driver level, so we don't support it. For example, multi-dimensional arrays. So we support 2-dimensional arrays. We support multi-dimensional with JDBC, but not with R2DBC. But for the most part, we've endeavored to have a similar experience across the board, depending on whether you choose to use a JDBC or an R2DBC driver. The actual reason for why one would choose to use JDBC versus R2DBC is very specific to the needs of the app in question. JDBC is the more standard traditional approach for apps, but there comes a point, maybe, for example, with high scalability or an increase in throughput, where the thread per request model and the blocking nature of JDBC may actually result in a critical bottleneck at that point, maybe R2DBC becomes more of a logical consideration, especially if you're trying to have a fully reactive stack and you're trying to leverage Kotlin coroutines from end to end. That's usually when we would suggest that they reach for R2DBC.
Yeah, it did sound like it's probably something that you would want to grab for performance reasons if it's asynchronous and to fit it into other existing APIs that you have. You also mentioned already that it also turns into like all suspending functions once you start using this, which makes a lot of sense from the Kotlin perspective. And of course, it fits nicely into the entire model of working with coroutines. If you're using that with Spring or Ktor and you have your scopes already and cancellation and all of these things, like it just fits into everything else that you have in a Kotlin application.
And regarding Kotlin coroutines, prior to V1 and prior to the introduction of R2DBC, there was the use case that you would be using a blocking JDBC driver, but maybe you still, alongside your blocking database operations, maybe you still wanted to use Kotlin coroutines. So there were these, I suppose you could call them bridging functions, top-level bridging functions that were provided to create suspend transaction blocks, even though you're using a JDBC driver, so that within the Lambda block, you can actually use suspend functions. So obviously with the R2DBC suspend transactions, that's a given that the transaction itself is suspend and it allows suspend functions in the Lambda block. But we chose to leave in the top level bridge functions in the JDBC module. There were some changes. We changed the name so that they align across the board. So the naming has been changed. We changed some of the arguments and we made the behavior align with the blocking transaction function. But still, the point is that if you want to use coroutines with the JDBC driver, it's still possible. It's just that the behavior has changed a little bit to be more aligned with the behavior, and that's regarding, for example, committing, rolling back, exception handling, for example, nesting of your transactions. That's aligned across the board, whether it's blocking transactions, suspend transactions, or the bridge suspend transactions on the JDBC side.
Yeah, makes sense. And yeah, it's probably easier to have everything in the same like suspending world than having to do the bits of interop between them.
Yeah.
My last question here around coroutines is either a simple question or major feature request, and I'm not sure which one it is. But can I also observe the state of the database with something like a flow, for example?
Oh, definitely. So, I mean, flow is practically everywhere in the R2DBC. So that is, I mean, it's not, flow is not currently, is there a feature request for that in JDBC? It's something in the back of my mind is niggling me that there was, and I'd have to look into that. But definitely with R2DBC, when you iterate over a query, everything is coming back as a flow.
And when values in a database change, like if the result of a query changes over time, can I observe that somehow?
You want to observe a query effectively. Like you want to get Google News alerts, but for your SQL query, like push instead of pull, I guess, kind of.
Interesting. Something tells me that what does a Kotlin Conf app do? Don't they do something similar? No?
For the backend part?
Yeah.
I think we're probably polling sessionize.
Oh, okay, sessionize. Okay. Then yeah, that sounds like that would be a feature request. I'm not entirely sure about that. I don't think that we do that. No.
I think this is one of the slightly trickier things, because you either need to somehow hook the database like in a very specific way to actually get triggers back, or you need to somehow
Mm.
be able to guarantee that every single query against the database runs through your stack, so that you can, like, i- in application
Intercept it.
code
Yeah.
outside of the database, like set dirty flags and like re-execute, like you're effectively building a reactive. Well, this is actually, I think, the trickiest and most annoying bit about this whole R2DBC story is that it is called reactive, and yeah, it includes the reactive part of, like, you can get things in reactive primitives, but you're not, like,
Yeah.
you're not treating it as like a reactive state, which is a little tricky at times.
Yeah, I don't know how frequent of a request this could be on the server side. Obviously, I'm coming at this mostly from a client side perspective, where we
Yeah.
love having databases that we can just continuously observe and then push that data to the UI, for example. But I'm very curious
Hmm.
if R2DBC itself even has a notion of this at all. Like I just don't know this.
Hmm. No, I'd have to look into that because that's not a use case that I've considered so far. Yeah.
I think this is a quite typical, like, front end pattern, like, quite a lot, because
It's a me problem, yes.
well, no, I mean, I completely empathize, because I think it is something that's really cool, because for me, like, I like coming the other direction and being used to like a lot of request response type operations. You kind of don't really think about this. Like, if your API responds you with something, well, then it's very clear when you need to run the query. You run the query when you start building the HTTP response. So on the back end, this is rarely a problem. But on the front end, when you have like a persistent thing that would like to keep getting data like pushed into it, or maybe also the question then is like, well, maybe I would like to emit things from a WebSocket or something
Mm.
into that. Um, this is where exactly this kind of stuff becomes interesting. But it
Yeah,
is
I was
just, yeah, it's a
I was
different
just gonna
pattern.
say, if you're doing like WebSockets or server
Yeah.
side event, the server sent events or something like that, I can see why you would want to do it like this.
Mm.
Yeah.
Mm.
So we've been at this for quite a while. So let's have a quick, like, little chill part of this. What's up with the mascot? It's very cute. The exposed mascot is very cute. Do you know what animal that is?
Well, do you remember what the original one looks like?
I vaguely remember it looking like a squid, I think.
Cuttlefish.
Ah.
Cuttlefish. And I believe that the new mascot is still a cuttlefish, maybe slightly less anatomically cuttlefish, but it is still supposed to be a cuttlefish. And I think the original story behind the cuttlefish was that it reminded the original. I mean, have you ever seen how a cuttlefish like hunts or hides, or how they're pretty enthralling, like animals to watch. So their skin has all these special pigment cells and these papillae or these protrusions, so that they can camouflage like experts in different
Mhm.
situations, and completely change how they look. And I think it reminded some of the original maintainers of the library of one of the core goals of Expose, which is that it should be able to mimic and blend in with any database or any of the supported databases, with minimal to no code change. And I think that's why they chose a cuttlefish. And then, we got a little bit of a rebrand, and it's much cuter now. Not necessarily as cute as Cody, but it's cuter. Yeah.
I mean, I really love it, and yeah, I mean, now that you've mentioned it, I do recall seeing a couple of like videos of like cuttlefish, and which where they like change the colors, which is that's honestly a really fun origin story, I gotta say.
Speaking of origin stories, can I share the history of Exposed because I have to tell somebody, and I feel like this might be the only place I get to tell people.
Yes, please, please, absolutely.
So I joined the team when the team was created in like April 2023. So that's when we were put together. But Exposed existed for far beyond that, like so far back that do you remember when Kotlin 1.0 was released ish?
Yeah.
So February 2016. And Exposed had already existed for 3 years before that. So
I did not know that.
Impressive.
yeah, so the first commit to the project was made in 2013. Everything that I'm telling you is what has been told to me by the original maintainer.
The lore is being passed down.
Yes, exactly. But the repo was started as an internal tool by a JetBrainer I've never had the privilege of meeting, and it was originally a proof of concept that a DSL with querying capabilities could be implemented using Kotlin. And after the POC was up, it was chosen to be used in another internal tool. I think it was a CRM of some sort, and it was chosen to be used in an internal tool to work with the database layer. But the internal tool was just a prototype. So Expose sort of existed. The sole purpose was to serve this tool. So whether it was bug features, fixes, it was all on demand. So the internal tool used MySQL. So in the beginning, Expose only supported two databases, H2 for local testing, MySQL for production, and it had a single core module. And yeah, that's when the original maintainer picked it up, and eventually this internal tool was launched, and Expose was kind of just maintained whenever it needed to be maintained, primarily by this single contributor in their free time. And then in 2016, Kotlin 1.0 got released. The Exposed repo became public, and there started to be more and more interest in Kotlin-first libraries. And it was in that year that apparently somebody from Spring approached the original maintainer with the idea to write an article about how to build a backend app using Spring Boot with Kotlin and Exposed as the persistence layer. And that article still exists. It's still online if anybody wants to read it. And so the interesting thing for me is that the second module to ever be implemented in Expose was a Spring transaction module to allow interoperability between Spring and Expose transactions. And that was in 2016. And, the rest is kind of history. We got more users, many more data types, more modules, more databases got supported. And, what's the math? 7 years later, the team finally decided to, work full time on Exposed. And here we are 3 years later with 1.0. So 2020, what are we? Yeah, 2026 versus 2013. It's been a while.
Hey, good things take time.
Yeah.
That's generally, like, having such a long story is quite incredible. It is also, I have to say, it is somewhat satisfying with this like origin story of like, someone just decided to hack something up, and then they kept adding patches and it kept working. And
Yeah.
I mean, I guess maybe that approach also explains a little bit of why a cleanup was necessary before the 1.0
Yeah.
release. Seems pretty natural.
Yeah. Yes. It was very on demand. So yeah, we're hopeful that, things will be a little bit different in the future, but yeah.
It just sounds pragmatic, really. You build what needs to be built.
Yeah. Yeah, and it wasn't a priority. It's not like they were trying to push expose. It was just this tool that they used to their benefit and they found useful and decided, hey, maybe the public will find it useful as well, and the public loved it. Like, and it's amazing, like the support that we have from individuals. I have met in person and virtually people who have been with Exposed since like the point single digit minor versions, and just for a reference, before we hit 1.0, we were at 0.61. And I've already told you the length of time, and there's users who have been loyal to Expose who were with us almost the entire step of the migration. They bumped to 1.0 beta and they bumped every beta, every RC. And I mean, I don't know how many of them are going to be watching this, but I hope they are aware that we are. It's humbling. It's unbelievable the continued support that we've had from people for over a decade. And it's my hope that with everything exciting coming up for Expose, it's my hope that we will continue to develop a product that they're happy to work with. Expose has had some great supporters, and I hope that they continue to stay with us.
It's a really really lovely story, I have to say. Like generally, it's always it warms my heart when technology resonates with people and people find this kind of loyal. Like people stick with tech for reasons. So I think this is also a great moment to like pat yourself on the back for all this kind of work that y'all have done, and the developers' lives that were touched or are touched by Exposed. It's super cool. With such a long history, how far has what Exposed is nowadays deviated from what it was like in the earlier days?
So what did the syntax look like a decade ago, I guess?
Yeah,
Ooh,
well, as far back as you remember, I
I was
guess.
gonna say, because yeah, decade, 15 years might be a little bit before my time. That would be interesting. So I can answer that from maybe two point of views, like you said, from the syntax that the users feel, and then from the maintainers, what's actually in the source code. Um, from the quite a fair amount has changed. Like, I have distinct memories of the documentation showing some examples that looked very different. Something as simple as like when you create the object table, the registration of the columns was always the same way, but then there were certain things that, for example, the primary key, defining the primary key on your table object was a column method that you chained to your column, whereas now it's its own subclass on the table class that you have to provide a column as an argument to. I'm sure there was a reasoning or rationalization behind that I'm not entirely aware of. It's like, some, but not that much of the overall object table definition has changed. The DSL itself has changed a little bit, even in my time, because that was one of our goals when the team was first put together. That there were certain clauses and certain steps that just didn't feel like SQL. So we changed quite a bit. We used to have a method called slice, which was supposed to mean select, and we've changed that now. We've tried to align more closely with the SQL. And then there's a lot of changes that I guess what we have to remember is how long ago it was. Things were built because of the way things were back then, and a combination of this is just what they needed. So the one thing that comes to mind, for example, is when you're using the DAO approach and you have an entity, you that entity usually has a type, a type that pertains to the identifier type of your table. So if you have a table where the primary key is an integer, you would have an integer entity. And at the time, all they needed or all they planned to use were identifiers that were the very Kotlin native types. So like integer, string, long, and so they were all comparable. They all implemented the comparable interface, and that just never really changed. But then, databases started allowing you to use different types as the primary key, and we started getting the argument that why are we being restricted to comparable types when the database isn't restricting us? So that was one of the things that we changed in one of our minor versions. We opened up the entity class, so now it's not dependent on comparable. So there's been some improvements like that. But from the maintainer point of view, how has it changed since the beginning to now? To be honest, other than the extraction pre V1, a lot of it is still very much the same. Like the foundation was very solid, and when I first started working with the Expose, I was usually quite constantly impressed by the layout and the decisions that were made. Yes, maybe you could argue it was a little bit of Jenga and things were piled on top. But to be honest, a lot of our base API, it wasn't completely changed or scrapped. It's just more that it was broken apart. So, just separated into maybe slightly new classes, but really like the core foundational table, column type, entity, they're all still there. Although I feel like that question would definitely be warranted to ask one of the original people that I know who've been there. It'd be wonderful if they had if we had a project that existed from like minor version 10 to now, just to see what like the history looks like. That'd be fantastic.
Maybe we need to do some archaeology in our free time.
Yeah. Or I suppose I could always, are those artifacts still available on Maven Central? I could always just reverse engineer it. I could like have a project and just start bumping down and seeing what it is that I need to change.
I mean, it's Maven Central is immutable, right? As a store, I think so.
Mostly.
They shouldn't be taking things down unless for good reason, because there might be somebody still depending on it out there. This might be your sign to update if you still are.
Yeah, but you're not. It's the truth though. Like where was it? So I'm not on Reddit anymore, but people, we still track Reddit, or somebody tracks Reddit for us, and there was a comment from somebody who legitimately, not maybe 2026, but end of 2025, was still using minor version 41, which is the version before when I joined. So they've not experienced any of the improvements that we've added or any of the features that we've added. So yeah, I wish them luck with the bump.
Maybe that's the real sign of having like satisfied developers, is when they don't even bother updating because they're like, "What else is there? This works. It's good."
I think that
It's
it
the
does say
perfect
a
version.
lot. It really does say a lot. Like it's impressive that there are people who are content staying on 41.1, and that's, hopefully they will also be content if they bump.
Yeah.
Yeah. Quick time check here. Do you still have time? Because we ran out of our normal recording slot.
Yeah, it's 11 a.m. by me. I'm more worried about the two of you. Are you not hungry for dinner?
We're fine.
Okay, then I think we can do a couple more questions. What I wanted to ask about is how does, if in any way, expose... The question I wanted to ask is, how does Exposed integrate with things like Spring and Ktor? You've mentioned the like ancient article about Spring support in some form for transactions, but what does this look like today? What do you need to know if you're working with one of these frameworks?
I'll answer about Ktor first because it's pretty seamless. Ktor goes very hand in hand with Exposed. It's actually how I came to know Exposed, because I was doing my own personal Ktor projects, and that's how I came across Exposed. Even if, for example, you decide to start a new Ktor project The Ktor project generator tool has an exposed plugin, so they will do all the setup for you, and then you can just hit the ground running. So integration with Ktor is quite seamless. You have a lot of different options, and there's many tutorials. There's many projects that exist that will help guide you through how to set up Ktor with exposed. With Spring Boot, it's also possible. We offer two different flavors of integration with Spring. So you can depend on our Spring transaction module, which it really offers only one class. It offers the exposed custom Spring transaction manager that essentially implements Spring's abstract platform transaction manager. This is currently a disclaimer. This is currently only available with JDBC. So you can either programmatically use that Spring Transaction Manager, but if you wanted, we also offer a Spring Boot starter that just provides everything for you, provides auto configuration, for example, so you can just hit the ground running with Spring Boot and exposed. We offer both Spring Boot 3 compatibility for those who have no intention of migrating to Spring Boot 4. And they will use the older artifacts that will be supported for the rest of V1. But moving forward, there is a Spring Boot 4 starter for those who want to migrate to Spring Boot 4. And that's actually one of the things that I'm working on currently. When V1 was released, the R2DBC support was not extended into Spring. So right now I'm actually working on a Spring reactive transaction manager so that we would also be able to provide a Spring Boot starter that plays well with R2DBC.
Is the main thing that these integrations doing the linking of transactions between
Exactly.
the framework requests and exposed?
Yeah, so at least with Spring Boot, for example, or with Spring, so you can choose how you use transactions. You can rely on the exposed. The manager allows you to rely on the exposed transaction, but you can also rely on Spring's annotation, transactional annotation. So you can rely on that. So you can use your DAO or your exposed DSL without exposed transaction block. And then at least for the JDBC, it also allows like JDBC client, the Spring JDBC templates and things like that, if that's what you choose to use.
Mm-hmm. And then is it something similar on the Ktor side? Is it also transaction linking of some sort?
For the Ktor side, it's where you still have to use an exposed transaction. It's more that for example, if you're using the Ktor server, it's more that you're using exposed as a persistence layer. You have your database connection, and then you're actually just setting up all the get, set, the HTTP protocols, and then you are creating, for example, a reusable transaction function. But then, whether you choose to use DSL or DAO is your own choice. But no, it's more, the Ktor integration is more, actually, it's much more, it's much more just seamless than that. Then it's not, there's no mix up of transactions or Ktor exposed transactions, no.
I guess the benefit of that is that Ktor is so unopinionated. It doesn't even have a built-in transaction of any sort in that regard.
Really, the one thing that I like, and I've noticed it quite nicely with the Ktor and Exposed projects that I have, is that you do your own little thing with Exposed in some files, and then I find that the only time that you really kind of, and then because usually I'll have something like a repository pattern, and that's what I'm using when I'm actually doing the get, set, post, put, for example. The only time that you actually really touch Ktor and Expose is usually when you're configuring your database on the application. And then that's when, you would call database connect, you would set up your environment and properties, and then you would actually initiate your schema, for example. But the rest of it is actually quite nicely separated or abstracted if that's what you want.
Yeah, it is so simple in a way that it's hard to talk about it, but you are
Yeah.
just calling functions. Like
Yeah.
like Ktor is also kind of just functions that you implement, and then you're
Yep.
kind of just calling functions on exposed and getting things back and then using them however you want. And yeah, the Ktor expose stack is actually really popular amongst my students, which I've seen a lot in recent years. That without teaching any of these libraries or frameworks, when they are building some kind of server-based project, they somehow very easily pick up this sort of thing on their own, and they apparently find it very easy to build like simple server-side apps, which is quite cool.
I've heard the same thing, that there's not a very steep learning curve, and that it's very easy to pick up. I find it hard to judge it myself, because I think I know a little bit too much about Expose, that everything seems a little bit easier for me. But I do have memories of when I first found Expose and like trying it and thinking, oh, okay, I create this table, I create these functions, I have an interface, and this class extend implements this interface, and then I just call those interface methods in this Ktor function, and that's it.
Yeah.
Yeah,
Like,
I can say that I happened to work with Exposed earlier this week, and I haven't had much of a history with it before, and so far, very smooth. I need to figure out how to do migrations, which is difficult mostly because I have no idea how our production setup works and what database it's running. But everything else that's on the Kotlin code, like actual sources side, is super easy to do.
We are, so we've done a few improvements to our migrations. I mean, pre V1, we introduced a new migration module with new migration utility methods that, allow the generation of SQL migration scripts, schema validation, and things like that. And that's actually one of the plans on our roadmap going forward, is that we're going to try to make migrations even easier. And one of the solutions that we're assessing is a Gradle plugin that was contributed to us. And we're assessing, it would basically simplify and completely automate the generation of these migration SQL scripts, so that it could be more easily, Expose could be more easily integrated, for example, with a tool like Flyway to actually apply the scripts. So it's on our plan to make migrations even easier, and also to like add tutorials for migrations and things like that.
very cool. If we're already talking about the roadmap a little bit, I think this might be a great way to somewhat wrap it up here. Are there any other things that are like on the immediate horizon for exposed development that are currently in research and development that are worth shouting out?
Sure, I could probably summarize what we may have talked about briefly, just to make sure I didn't miss anything. I mean,
Sure.
right now we're assessing feedback from the 1.0 release in January. There's a couple of small features that just didn't quite make it into 1.0, so we're triaging to see what we can get into the next minor. There's some new tutorials that we're working on beyond the basic DSL and DAO tutorial that are already live on the documentation website. As I mentioned, we're working on supporting R2DBC with our Spring interoperability, so that's coming up. And then the big boys that we're working on the roadmap, we're trying to do a lot of integration and simplification. So we've got that migration Gradle plugin coming up. We're looking at potential solutions and plugins, for example, for data class, auto generation of conversion functions, reducing boilerplate with the IntelliJ IDEA plugin, so that you don't have to create manually tables and entity classes from your existing schema. And the big overarching roadmap feature that is currently, there's already some proof of concepts, but the goals, or the what we hope to achieve, is quite broad. So it's taking a while, is the redesign of DAO. There's a couple pain points with DAO that have been addressed before. There's a first level cache. It has occasionally had some areas that are maybe a bit more confusing and hide more than we want to, because one of the tenets of Expose is that we want to be transparent. So the cache maybe could use some improvements. We're considering potentially adding a second level cache as well. There's a lot of design choices about the entity class themselves that are not extremely ideal. For example, the entity classes are not serializable the way that other classes could be. They're also quite tightly coupled to particular exposed constructs like transactions and connections. So it's not as easy to use these exposed entities in your testing, like when you're mocking, for example. So that's probably the biggest roadmap plan coming up, which is, we're taking a very deep dive into the DAO, seeing what we can improve. The goals being make it easier, more enjoyable to use, reduce boilerplate, so people can get started sooner using DAO.
I mean, there's a lot going on. It sounds like,
There's
and
a lot.
yeah, I'm excited for the immediate and longer horizon future both of Exposed here.
We are too. And yeah, it's we've been getting a lot of feedback so far. We're hoping to get more. And yeah, there's always going to be little things that sprinkle in here and there. We're still, accepting feature requests. We're still, trying to fix bugs. Maybe sometime in the future we'll support other databases. Who knows? So yeah, it's exciting.
So where would people go if they wanted to get feedback on any of these? On the 1.0 or on the feature requests, or if someone hasn't tried Expose yet, what's a good place to get started?
So first place that I would start is the documentation website, which is somewhat new. There was a time when the only documentation that existed for Expose was the GitHub wiki. And now there is a documentation site. It's just the jetbrains.com/help/exposed. But there's also an actual dedicated landing page for Exposed now on the jetbrains.com/exposed, and it has a link to the documentation. It has Exposed to the GitHub, has Exposed. It has access to the GitHub tutorials, for example. But in my opinion, the two best places to start would be the Kotlin Lang Slack. We have an Exposed channel. It's a very nice community to be in. We track it, we monitor it, but I have noticed an uptick in just, community helping community. It's really nice. You can go there, you can ask questions. Sometimes we'll respond, sometimes the rest of the community will respond. It's also a really great place to get kind of like a overarching view if you have any problems, not just specific troubleshooting. If you actually have issues and you want troubleshooting, I'd recommend going to UTrack, to the Exposed project page on UTrack. Even if you don't have issues to report, there's a lot of really interesting discussions that are happening on UTrack right now. Go in, search for a keyword that interests you, leave a comment. You're interested in KMP support, you're interested in Spring support. Like, there's a lot of really interesting discussions that are happening on UTrack right now.
Very good. Well, Márton and I are intimately familiar with our wonderful UTrack instances. It's a great place to hang out if you want to learn about all the things that can still be improved, and where you can leave all your opinions on all things Kotlin, really, which is quite fun. Yeah, very cool, very lovely. Well, Chantal, thank you so much for coming on today. It was quite an extensive chat that we had here. The time has a matter of running away from us, but I think it was well worth diving into this. I was an Exposed fan before, and I think now I'm doubly so an Exposed fan, even more. So yeah, really appreciate all the insights, all the deep dives. Yeah, and getting to learn a little bit more about what makes this wonderful database library tick.
Well, thank you for having me. Thank you for giving Expose a little bit of a platform. Thank you for listening to me ramble. I could probably do it for a little bit longer, so I apologize if I went into tangents.
That's just a good it's a good sign for a potential follow-up episode sometime in the future.
maybe, yeah.
And of course, I want to also say thank you to everybody who decided to tune in again today to our episode. If you're an Exposed user, let us know in the comments. Let us know what version of Exposed you're on. Lowest version wins bragging rights. I don't know. That's encouraging the wrong behavior, I think. Oh well. Well, I hope that we'll, of course, see all of you in a future episode. Thanks for tuning in and have a lovely Kotlin. Take care, everybody. Bye bye.
Bye.